Hello everyone. In this video we will learn about the binomial theorem for any index. Any index means it is not necessary that the index n is a positive integer. It may be a fraction or it may be a negative number. What we do in such case? See, we have already learnt about the binomial expansion for n to be a positive integer. And that is x plus a whole power n is equal to x power n plus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square plus so on ncn into a power n. And here we know that the number of terms in this n plus 1. That is because n is a positive integer, that is a definite number, so the number of terms also is definite. But in case it is a fraction or it is a negative integer, then the expansion will be having infinite number of terms. What we do for that? We will replace x by 1 and a by x. Then what will happen? It will be 1 plus x power n is equal to 1 power n plus nc1 into 1 power n minus 1 into x plus nc2 into 1 power n minus 2 into x square plus so on. There will be infinitely many terms in this. We also know that nc1, nc2 etc. the combination can be used only if n is a positive integer. But if it is not a positive integer, we will be using the values of them in the terms. So we can write this as 1 plus nc1 is n, we already know it. 1 power n minus 1 is 1 into x plus nc2 we know n into n minus 1 upon factorial 2 into x square plus n into n minus 1 into n minus 2 upon factorial 3, this is the value of nc3 for the next term, into x cube plus so on. So this will be the expansion we will be using in case n is not a positive integer. If we make it x minus a whole power n, in that case, this will be 1 minus x or not. So we can write if x is replaced by minus x. In that case, this expansion will be 1 minus x whole power n equal to 1 plus n into minus x plus n into n minus 1 upon factorial 2 into minus x square plus n into n minus 1 into n minus 2 upon factorial 3 into minus x whole cube plus so on, which is equal to 1 minus nx plus n into n minus 1 upon factorial 2 into x square minus n into n minus 1 into n minus 2 upon factorial 3 into x cube plus so on. So we find that the alternate terms are negative in this, and that is because the even power of minus x is positive and odd power of minus x is negative. So we have learnt that the binomial expansion for any value of n can be found by using this type of form, that is 1 plus x power n or 1 minus x power n. This is 1 and this is 2. The general term in such cases will be when we find the general term for 1, that is tr plus 1 equal to n into n minus 1 into n minus 2 into n minus r plus 1 upon factorial r into x power r. That is because you find here that when power 1 it is only n, when x power is 2 then we are finding this is n minus 1, 1 is 1 less than 2. When it is x cube Then this is n minus 2 is the last factor, which is we are finding 2 is less than 3 by 1. And same, whatever the power of x is coming, same is here in the factorial. And that's why this is the general term, that is n into n minus 1 into n minus 2 up to n minus r plus 1 upon factorial r into x power r. Similarly, the general term in case of number 2, that is when it is 1 minus x. For 2, the general term will be tr plus 1 equal to n into n minus 1 into n minus 2 into n minus r plus 1 upon factorial r into x power r into minus 1 power r. That is because it is minus x power r, or we can write x power r into minus 1 to the power r. This r will tell us whether this is to be a negative term or a positive term. If r is even, this will be positive. If r is odd, then it will be a negative term. We discuss now one example based on the same, and that is find the expansion of 2 plus 3x whole power 5 by 2. 2 plus 3x whole power 5 by 2. Here we find that n is 5 by 2, which is not a positive integer. So we can use this form. To convert it into this form, this 2 should not be here. So we can take 2 common and make it 1. So this can be written as 2 power 5 by 2 into 1 plus 3x by 2 whole power 5 by 2. And now we can make use of this expansion. So we are writing here 2 power 5 by 2 1 plus n into x, that is 5 by 2 into 3x by 2 plus n into n minus 1 upon factorial 2 into x square means 3x by 2 square plus 1. When we simplify this, this is 2 power 5 by 2 into 1 plus 15x by 4 plus, this is 5 by 2, 5 by 2 minus 1 is 3 by 2, factorial 2 is 2 into 3x by 2 whole square means 9x square by 4 plus 1. On simplifying, we get 2 to the power 5 by 2 can also be written as 4 root 2 into 1 plus 15x by 4 plus 5 3 ja 15 9 ja 135 upon 2 to the 4 to the 8 4 ja 32 into x square plus so on. This is the way we can write the expansion for any of the binomial given to us if n is not a positive integer. When n is negative, what is the change in the binomial theorem? Let's learn now. See here for the first one, when it is 1 plus x power n, if n is negative, we will replace this n by minus n. So for 1, replace n by minus n. We get here 1 plus x whole power minus n, and this will be 1 plus minus n into x plus minus n into minus 1 upon factorial 2 into x square plus minus n into minus n minus 1 minus n minus 2 upon factorial 3 into x cube plus so on. When we simplify, we are getting it as 1 minus nx plus n into n plus 1 upon factorial 2 into x square, because when we take minus 1 common from this, minus into minus becomes plus. Here we have 3 factors and all are negative. If we take minus common, minus into minus will become negative. So it will be negative here, and this will be n into n plus 1 into n plus 2 upon factorial 3 into x cube plus so on. So what change we are finding here is, first thing, alternate terms are negative. Second is that the factors are not n minus 1, n minus 2, etc. They are now n plus 1, n plus 2 and so on. Same way, in the second one we replace n by minus n. Then this will become 1 minus x power minus n. It will be 1 plus nx plus n into n plus 1 upon factorial 2 into x square plus n into n plus 1 into n plus 2 upon factorial 3 into x cube plus so on. All the terms will become positive. Why? Because minus into minus will make it plus. And the general term in these cases will be tr plus 1, that is n into n plus 1 into n plus 2 into so on n plus r minus 1 upon factorial r into minus plus x power r. This is because when r is odd, this will be negative in the first case, and when it is even, this will be positive. Whereas in this case, we will be using only the positive one because all the terms are positive. We discussed now about some of the special cases when n is a negative integer. Suppose it is 1. Then we will put n is equal to 1 in 1. First of all, we are taking the first case. It will be 1 plus x power minus 1 equal to 1 minus 1 into x plus 1 into 1 plus 1 upon factorial 2 into x square minus 1 into 1 plus 1 into 1 plus 2 upon factorial 3 into x cube plus so on. And we find here it is 1 minus x plus 2 and 2 will cancel, x square minus 2 3 are 6 and this is factorial 3 6, they cancel, it is x cube plus so on. When we put n is equal to 1 in 2, this will be 1 minus x power minus 1 and all the terms will become positive, 1 plus x square plus x cube plus so on. If we put n is equal to 2 in 1, we are getting 1 plus x power minus 2 will be equal to 1 minus 2x plus 2 into 2 plus 1 upon factorial 2 into x square minus 2 into 2 plus 1 into 2 plus 2 upon factorial 3 into x cube plus so on. On simplification, we are getting this is 1 minus 2x plus 2 and 2 will cancel, 3x square minus 2 into 3 will cancel factorial 3 and this is 2 plus 2 4 x cube plus so on. If we put n is equal to 2 in 2, then it will be 1 minus x power minus 2 and all the terms will become positive. So it will be 1 plus 2x plus 3x square plus 4x cube plus so on. If we are putting n is equal to 3, then the first one will give us 1 plus x power minus 3 is equal to 1 minus 3x plus 3 into 3 plus 1 upon factorial 2 into x square minus 3 into 3 plus 1 into 3 plus 2 upon factorial 3 into x cube plus so on. And this will give us 1 minus 3x plus 3 into 4 12 upon 2 6x square minus 3 into 4 12 and this will cancel 2 into 5 10, so it will be minus 10x cube plus so on. Like this, we can remember some of the expansions when n is a negative integer. In the next video, we will learn about the applications of binomial theorem. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.